Okay, I wanted to go over the notes that you guys took today while I was gone, and we're going to learn how to take an equation that has lots of fractions, do a little prep work to get rid of those fractions, and then solve the equation with much easier numbers. So our objective today, oops, I always leave a weird color. So our objective is to understand what LCD means. We're going to find the LCD to, let's see, for a group of fractions. And we're going to learn how to eliminate fractions from any, and here comes the key word, I'm going to write it real big and in red, equation. This is not a strategy that works with all sorts of math. It only works in equations. Okay, so that's our job today, is to figure out how to eliminate fractions from any equation, or as the title of the notes that you copied said, clearing an equation of fractions. So let's start with LCD. LCD stands for least, there's the L, common, there's the C, denominator, and that is the D. So we're trying to find the denominator that it has the smallest value in common with a group of denominators. So it's the number that all denominators go into evenly. Okay. So we're going to practice just this notion of how do we find an LCD, and I'm going to give you a lot of different strategies to use. So I'm going to go to the next screen so that we can work through this. All right, so the directions are going to say find the LCD. So this is going to be a crucial part of the process when we're learning how to clear the fractions from an equation. So first off, we're just going to give you a group of fractions. Here I'm only going to give you two. So I have 1 and 3, 2 and 5. Okay. So a couple things that you need to pay attention to is what kind of numbers are in the denominator. And if you notice, you've got 3 and 5. And 3 and 5 have the distinction of being particular types of numbers. 3 and 5 are called primes. Prime numbers have only two factors, the number itself and 1. When you have only primes in your denominators, what you're going to do is multiply the primes to get the LCD. So multiply primes to get LCD. So this is one strategy. Now you can use this strategy all the time to figure out your LCD, but it's not going to give you the least common denominator, so you might be multiplying by a number larger than you need to. Okay, so the LCD for this problem is 15. So to eliminate fractions where you had 1/3 and 2/5, you would be multiplying by 15 to eliminate the denominators. Okay, 2. I'll give you 3 fractions, 1/2, 1/3, 1/6. Now I look at these numbers, and 2 and 3 are considered primes, but 6 is not. It's composite, and composite means it has more than 2 factors. 1 times 6, 2 times 3, so I have 4 factors that give me that. So what I'm going to use is a strategy called a factor ladder that you may have used. So you're going to take your denominators and you're going to list them all in one row. And then you're going to put this, kind of looks like a division symbol, upside down. And this one's, you may have used this to find a common factor, so something they all three have in common. Well, we can use this one differently. What we want to do is see if there's anything that two or more of them have in common. So what you say is, let's see. Well, 2 and 6 are even, so they have a 2 in common. So what you do underneath is you list what you get when you take the original number and divide it by this common factor 2. So in other words, 2 divided by 2 is 1. Now, I cannot divide 3 by 2 evenly, so I don't get to do division, and I just bring him down. And then 6 divided by 2 is 3. So then you look and you ask yourself, is there anything that 2 or more of them have in common? And you look and you say, sure enough, 2 of them have 3 in common. So you try to divide each of them by 3. Now you cannot divide 1 by 3, so you just bring down the 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So you are done with this process if all the numbers end up being 1, like in this case, or there are no 2 values at the bottom that have a factor in common other than 1. So we're not done yet. What we're going to do is take all these numbers that are outside the factor ladder and we're going to multiply them together. So we get 2 times 3 times 1 times 1 times 1 equals 6. That is your LCD. If I multiplied those fractions by 6, it would eliminate all the fractions. Okay. Now in a minute I'm going to show you exactly how it works in the problem. All right, let's try another one. We've got 3/4, 5/8, 1/16. Now I can use this factor ladder. I could multiply all the denominators, but that would be one big huge number. So there's another strategy you might use, and this strategy might be called pick the biggest. So what you're going to do is look at 16 and ask yourself, can you divide 16 by the other numbers? Because I can divide 16 by itself and I get 1. Can you divide 16 by 4 evenly? And the answer is yes. So it works for that number. Can you divide 16 by 8 evenly? And it goes in twice, so it works for that. So what that tells me is that all three of those numbers go into 16 evenly. Therefore, the LCD is equal to 16. Okay, one more. So we've got 1/2, 3/4, and 2/7. So this strategy, I don't like this one very much at all because I think it takes too long, but I'm going to show it to you anyway because I know you may be familiar with it. So what you're going to do is you're going to take each of those denominators and you're going to start listing multiples. Now I'm going to do it in an intelligent fashion. So I'm just not going to blindly say, oh, I'm going to list 5 of each of them because that's going to create more work than I need to do. So what I'm going to do is I'm going to list start with the biggest guy and list his multiples. Well, 7 times 1 is 7. And then I stop and ask, well, can 4 go into 7? No. And as soon as I get an answer of no, I stop. So I try the next. 14 would be 7 times 2. So can 4 go into 14? No. So I stop. I can't do anything more. So the next multiple, 7 times 3 is 21. Can 4 go into 21? No. So I stop. The next 7 times 4 is 28. Can 4 go into 28? The answer is yes. And here I can show that to you. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7. So we've got a match. Can 2 go into 28? And the answer is yes. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Notice I'm running out of room. 22, 24, 26, 28. So eventually I find that all three of them have the same one. So instead of me writing this all out, what I end up doing is I end up stopping with each multiple of the largest one and seeing if my other numbers can go evenly into it. If they both go evenly into it, then that's the multiple that will work. So in this particular case, it took me a little while to get there, and I have the LCD as 28. So you have all these different ways to find LCD, and you just got to kind of stick with the one that works best for you. All right, so let's talk about how are we going to use this idea of LCD with eliminating fractions. So that's what we're going to work on now. To clear fractions, from here's the, again, and I'm going to write it large and in red, equation. So this only works in the situation of an equation. You're going to multiply, and here comes another biggie, each term in the equation by the LCD of the fractions. Okay, so let's go and try this out. And this is the only strategy you get to use. If you leave them as fractions, you're actually not going to get points on a quiz or test. I'm going to definitely require you to show me this technique. So we're going to clear fractions from each equation, then solve. So first problem, we have 2/3 x plus 1/2 x equals 5/6 plus 2. So what I need to do is figure out the LCD of 3, 2, 6. Now some of you can just look and say, oh, that's easy. 6, the bigger number, 3 goes into it evenly and 2 goes into it evenly. So we can say that it's going to be 6. So what I'm going to do is multiply everything. And when I say everything, I mean everything. I don't care if it isn't a fraction, you multiply by it. How is this going to help me? Well, 3 goes into itself evenly, into 6 twice. 2 goes into itself evenly and into 6 3 times. 6 goes into itself evenly and into itself evenly. And then I just have a new product at the other end. So what I'm left with is 2 times 2, which is, 4, and then there's an x, plus 1 times 3x is 3x. 5 times 1 is 5, and 2 plus 6. Oh, you know what? I'm sorry, I made a mistake. My mistake was I wanted this to be 2x. So when I multiply 2x times 6, I get 12x. Okay, so then I simplify. I notice on the left side that they are like terms, so I'm going to combine them up. And I get 7x equals 5 plus 12x. And remember, we want to take our variables to the left. So we're going to subtract 12x from both sides. And we end up with negative 5x equals 5. And then we're going to do opposite of multiplying by negative 5 is dividing by negative 5. And we get an answer of x equals negative 1. Okay? And that's my solution. All right, I've got 2 more I want to go over with you. And again, I'm going to show you different techniques on these for solving. So second problem. We have 7/8 x plus 3/4 equals 1/2 x plus 3/2. So I need to find the LCD of 8, 4, 2. Notice that I have 2 twice, so I'm not going to list it. So let's use that factor ladder to help us out. All right, do you notice something that can go into 8, 4, and 2? And what you might say is, well, yeah, they're even, so I'm going to divide a 2 out. 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Okay, is there something that 2 or more of those factors have in common? Yeah, we still have 2 evens. 2 goes into 4 twice, 2 goes into 2 once, 2 can't go into 1, so I just leave it like that. Then I'm going to take all these guys on the outside, and I'm going to multiply them. And I get 2 times 2 times 2 times 1 times 1. And that's going to give me 8. So it ended up being the large number. So my LCD is going to be 8. All right, since I took up so much room, I'm going to rewrite the problem over here and do the work. So I get 7/8 x plus 3/4 equals 1/2 x plus 3/2. So what I'm going to do is multiply everything by 8. And I show this every single time. And 8 goes into itself once and into itself once. 4 goes into itself once and into 8 twice. 2 goes into itself once and into 8 4 times. 2 goes into itself once and into 8 4 times. 7 times 1 is 7, so I get 7x. 3 times 2 is 6. 1 times 4 is 4, and I get the x. 3 times 4 is 12. Now, isn't that a much easier equation to deal with? So, I have no like terms on either side, so I'm going to start doing opposite operations to get variables on the left. Subtract 4x from both sides. I get 3x plus 6 equals 12. I'm going to do constants to the right. Opposite operation, subtract 6 from both sides. And I get 3x equals 6. Divide both sides by 3. Oops, 3. And then I get x equals 2. And that's a solution to this problem. Okay, we got one more for you. We have number 3. 5 6x plus 1/2 equals 2/3 x plus 4. So I think what I'm going to do is deal with my LCD over to the right so it doesn't interfere with my solving, and I need to figure out the LCD of 6, 2, and 3. And we already did that in the first problem, and so we know that the LCD is the larger number 6. So that's what I'm going to multiply everything by. I'm going to multiply everything by 6, regardless if he has a fraction or not. So 6 goes into itself once and into itself once. 2 goes into itself once and into 6 3 times. 3 goes into itself once and into 6 twice. And then there's no denominator here, so I'm just going to multiply out. So 5x times 1 is 5x, plus 1 times 3 is 3. 2x times 2 is 4x, and 4 times 6 is 24. I look for any like terms. I don't have any, so I'm ready to do opposite operations. I'm going to go to the left with my x's. I'm going to subtract 4x from both sides. That gives me 5x, take away 4x is an x, plus 3 equals 24. And then I'm going to go to the right with my constants. Opposite would be subtracting 3 from both sides. And I get x equals 21. And there's my solution. All right, I hope that helps. Good luck.